All right, in this lesson, we're going to be simplifying rational expressions. Now, here's the plan of attack. We're going to factor the numerator and the denominator completely, and then we'll cancel the matching factors. Only if you created the breakpoint. Remember, a breakpoint is where they're multiplying. It's a multiply spot, okay? It's a breakpoint. Now, the directions will say simplify and state any restrictions on variables. Now, restrictions, what do I mean? Well, we have to be careful that we don't divide by 0. So the restrictions that you're going to set have to do with the denominator. So you're going to set every denominator, whatever factors in the denominator, not equal to 0 because we can't divide by 0. Remember that rule? So let's try this. Look at number 1. So we're factoring trinomials. All right, so in number 1, let's look at this, the numerator. What two numbers multiply to be -3 but add to give you -1? Well, it would be a 3 and a 2. The 3 has to be negative, and the 1 has to be positive, okay? The denominator, what two numbers multiply to 4 but give you 5, positive 5? That would be an x plus 1 and an x plus 4. Now I look, see the factors I have in common, the x plus 1 and the x plus 1, they will cancel out. So I'm going to leave what's left over as my answer. Now, that's part of my answer, but now I have to do my restrictions. Now, when you cross them out, don't cross them out so you can't see them, but notice what's left over in the denominator. X cannot equal a -1, right? If you set that factor right here equal to 0, it will be, x will be -1. And x cannot equal a -4. So this one happens to have two restrictions. Let's try the next one. Let's factor the top. What two numbers multiply to -12 but add to 4? That would be a 6 and a 2, so x plus 6, x minus 2. All right, and the denominator, if I factor the denominator, two numbers multiply to -6 but add to +1. That would be an x plus 3, x minus 2. So I notice the x minus 2 factors will cancel. So my answer will be x plus 6 over x plus 3. Now my restrictions have to deal with the denominator, right? So I have this one, it's x cannot equal -3. And you can write them as a list, x cannot equal a +2. All right? That's not a problem. You can write them separately like we did right here, or you can write them as a list as we did in number 2. It's not a problem. Let's jump to number 3. The numerator really is already factored, isn't it? So it's 3x. The denominator, let's take a GCF out. If we take 3x out of both, I have x minus 3. Now, notice the 3x's cancel. So what's left over, you can't leave a 0 in the numerator. You need a placeholder, so make it a 1. And the x minus 3 is in the denominator. So let's talk restrictions. X cannot equal, well, 3x equals 0 means that x equals 0, right? Or cannot equal 0, I should say. Cannot equal 0, and x cannot equal a 3 for this one, all right? Now, just notice, make yourself a little note here. Anytime you have an x in the GCF right here, you're going to have a 0 in your list of restrictions. It's just what happens. So let's just make a note. If x is in your GCF, 0 will be in your list of restrictions. Okay? Just food for thought there, okay? Now, let's go back to our questions. Let's look at number 4. Looks like the numerator can be factored here. Start with the GCF. So let's take out a 3 of x squared minus 9 over x plus 3. Well, nothing's canceling out yet, so I need to keep factoring this top. Hopefully you recognize this as a difference of squares. So x plus 3, x minus 3 over x plus 3. Now my x plus 3's will cancel out. And my answer, I'm going to be left with 3 times x minus 3. Now, I canceled out the bottom. I don't have to put it over 1. You can, but traditionally we don't. Now, what about my restrictions? Well, there's only one factor in the denominator, so it's x cannot equal a negative 3. It's that quick. One last example. Now, this one's different because notice this 3 right here. That 3 right there means I'm going to have to go back to old school grouping for factoring, all right? Because of that 3. Remember on all these other ones, we've been able to use the shortcut because there was a 1, a leading 1. This one you can't. We're going to have to group. So we have a little extra room here, so let's do this. We're going to have to multiply on this one to negative 12, and we're going to add to a positive 1. So 4 and a 3. I need the 4 to be positive and the 3 to be negative. Okay, so coming back to the question, the 3x plus 4 is the factor on the top, easy enough. The bottom, let's keep factoring this down here, 3x squared. Remember, we're replacing the plus x with plus 4x minus 3x minus 4. And then we group them. What do we have in common? An x, and we'll have 3x plus 4. Here I bring down the minus. What do these have in common? Nothing but a 1. And then I'll have it, remember I'm dividing a negative 1 out, so it'd be positive 3x plus 4. So then my two factors will be 3x plus 4, and what's left over? X minus 1. All right, now I see a factor that will indeed reduce. Okay, so but notice I canceled everything out of the top. It's not 0, it's a 1. So put that 1 there. Now let's talk restrictions. All right, if you take this 3x plus 4, can you do this in your head? If it's not equal to 0, what does that mean? Well, I jump the 4. So I'll have 3x equals negative 4, divide by 3. So x cannot equal negative 4/3. So this is a little different. And then this one, the x minus 1, makes a restriction of positive 1. All right, there you go. That is how we reduce rational expressions. I hope it makes sense to you. And let me know what questions you have when you get to class. Good luck.